All right, trig homework 22 is having you find the period and the amplitude of the function. Keep in mind that standard form for sine and cosine is that I have y equals a, and I'm just going to use sine of bx. The amplitude is the absolute value of a. So the amplitude they always give is a positive value, even though it might go down first, it's still a positive value. Your period is found by taking 2 pi divided by b. So they will switch these two things around. If I'm going to do my period first, I'm going to take 2 pi divided by my coefficient of x here, which is 3/4. Since I'm dividing by 3/4, I have to invert and multiply. So 2 pi times 4 over 3, which gives me 8 pi over 3. Wrote that kind of big. My amplitude going to be the absolute value of 4, which just gives me 4. So my period, 8 pi over 3, my amplitude is 4. On my second one then, again I'm going to have my cosine function. This is my a and this is my b. My period is 2 pi divided by b. So I'm going to take 2 pi divided by 2 pi over 3. So again, I have to invert and multiply. 2 pi times 3 over 2 pi. Here the 2 pi is going to cancel out. So my period ends up just being the 3. My amplitude is the absolute value of a, so the absolute value of -3 is 3. So on this one, both my period and my amplitude ended up being 3. And the third one says find the period and amplitude of the function. Give the exact values, not decimal approximations. So again, my period is 2 pi over b. The b on this one is 4. So 2 pi over 4 is going to reduce down, and so I get pi over 2. Amplitude would be the absolute value of a, which is 2/3. The absolute value of 2/3 is still 2/3. So my period, pi over 2, my amplitude, 2/3. Normal period for a sine curve without anything in front is 2 pi. Amplitude is normally 1 because normally I have 1 in front of that. So here we're doing the amplitude, period, and phase shift of the sine and cosine function. General form, we have a cosine of bx minus c. Amplitude of a is the absolute value of a. Period, again, 2 pi over b. My phase shift is c over b. Be careful because in here we have that minus sign. So c ends up being the opposite of what you think that is up there. So for my period, I'm going to do 2 pi over the b value, which is pi. And so I'm going to get a period of 2. My phase shift, I'm taking the c value. Now notice this is a plus c, so I would have had to have minus and negative. I would have minus pi over 3, so the opposite sign here. I'm going to divide it by pi, which means I'm going to have negative pi over 3 times the reciprocal, and those are going to cancel out. So negative 1/3 is going to be my phase shift. My amplitude, the number in front of here, the absolute value of 2 is going to give me 2. So my period was 2. My phase shift, negative 1/3. My amplitude is 2. So number 5, same thing. They switched them around, find the phase shift, the period, and amplitude of the function. And so for my phase shift, I'm going to do c over b. So c here is a positive pi over 4. I'm going to divide it by my b value, which is 3. So pi over 4 times 1/3 would give me pi over 12 for my phase shift. My period, 2 pi divided by b. So I'd have 2 pi over 3 for my phase shift. And my amplitude, the absolute value of A, so the absolute value of -4, going to give me +4. So my phase shift was pi over 12, my period 2 pi over 3, and my amplitude going to be 4. And now I got to move the board. So number 6, they're going to start by doing the period first. So 2 pi over the B value of pi, which gives me a period of 2. My amplitude, the absolute value of A, so the absolute value of 3 is 3. My phase shift, my C value, remember that has to have the opposite sign, so -pi over 4 divided by pi. So -pi over 4 times 1 over pi gives me a -1/4 for my phase shift. So my period is 2, my amplitude is 3, and my phase shift -1/4. Writing the equation of a sine or cosine function given its graph, these ones we're going to write in the form of y equals a sine of bx or a cosine of bx. The a again is your amplitude, your b is your period. So first of all we have to decide if we have a sine curve or a cosine curve. We don't have any phase shifts, so if it starts at 0, 0, that's going to be my sine curve. If it either starts up or down, that's going to be my cosine curve. So I know this one is going to be the sine. My amplitude, this one is going up first to 5, so my amplitude is 5. If it will go down, my amplitude is still 5, but I'm going to have a -5 in front of my sine to indicate that it's going down. So this one's going to go up to 5, so there's a 5 in front. And then I have to know that for the period, we have 2 pi over b, and I look to see what the period is. This one goes from 0 to do 1 complete cycle, it's 8 pi over 3. So 2 pi over b equals 8 pi over 3. I'm going to cross multiply to solve. So 8 pi b equals 6 pi. I'm going to divide by my 8 pi. So b is going to equal, pi's cancel out, I can reduce that down to 3/4. So my b value is 3/4, so I have 3/4 x. So y equals 5 sine of 3/4 x. Don't really need the parentheses, but if you want to put the parentheses there, you could put the parentheses there. Be the same answer. Number 8, if I'm looking at that one, again, we don't have any phase shifts left, so I'm seeing that it starts up here at +3. So since it starts up here, it's going to be the cosine curve. And so I know I'm going to do the cosine. My amplitude is 3 and it's positive. Amplitudes are always positive, but I go up first. And then my period. So 2 pi over b is going to equal, to do 1 full cycle of a cosine curve, I'm ending back up here, I would be at 8. So solving that, 2 pi would equal 8b, dividing by 8. I get pi over 4 for my b value, so I would have pi over 4x. Again, I could put the parentheses around there. Y is going to equal 3 cosine of pi over 4x for my equation. Number 9, looking at that one, it's crossing at 0, 0 to begin with, so I know that I have the sine curve. Again, this one's going up first to 2, so 2 is my amplitude. My period on this one is 8 pi to do 1 full cycle. So 2 pi over b would equal 8 pi. 2 pi equals 8 pi times b then. If I divide by 8 pi, those cancel out. I get 1 over 4 for my b value. So 1/4 x. So y is going to equal 2 sine of 1/4 x, going to be the equation of my sine curve. The next ones, we are writing the equation of the sine or cosine function given its graph. This is problem type 2. Again, we're not going to have a phase shift left or right, but we are going to have a shift up or down, which means we end up adding or subtracting a number from the end. We're going to start these ones just like we did the previous ones, where we were putting them in the form of either sine or cosine of bx, but this time we're going to have a plus or a minus value here on the end because my graph is going to shift up or down. So what I want to do first of all is figure out where the middle of my graph is. So if I cut this in half, the middle is right here. So instead of being at 0, it's shifted up 1. So I know that I'm going to have a plus 1 on the end of my graph. So if I'm at 0, I'm starting down here. So I know I'm going to have the cosine curve. I have 1, 2, 3, 4 down. So my amplitude is 4, but I'm going down first, so I'm going to have negative 4 in front of my cosine. Here I should go 1, 2, 3, 4 up. Yep. So it's starting down here, going up, and ending over here. I still need to find my b value. My period is 2 pi over b. One complete cycle is going to go from here to here, so my period is 8 pi over 3. And so if I solve that, I'm going to have 8 pi b equals 6 pi. Divide that by 8 pi, reduce it down. Dividing by 2, I would get 3/4 for my b value. So I'm going to have 3/4 x. And so y is going to equal negative 4 times the cosine of 3/4 x plus 1 because my graph shifted upward. So on number 11, if I look at my graph, again, this one has a shift to it. If I look for where the middle of this graph is, the middle of my graph would be right here. So it ended up shifting 1, 2, 3 down. And so I'm going to have a minus 3 on the end. So if I think of this as normally like my x-axis, this one again is going to be the cosine curve. It's starting 1, 2 up. So I'm going to have 2 times the cosine. And then one complete cycle ends over here at 3. So 2 pi over b is going to equal 3. 2 pi would equal 3b. Dividing by 3 then, 2 pi over 3 is going to be my b value. So I'm going to have 2 pi over 3x. And so y is going to equal 2 times my cosine of 2 pi over 3x. Minus 3 because my graph shifted down to negative 3 to find the center of my graph. And number 12, I guess I don't need to move the board to do that. We can probably do that right here. Looking for where the center of my graph is. So the center of my graph here again looks like it shifted up 1. So I'm going to have a plus 1 on the end. If this is my starting point, this looks like it's going to be the sine curve. It is going 1, 2, 3 up. So 3 times the sine of something. My period, 1 complete cycle equals 1. So 2 pi over b equals 1. So b is going to equal 2 pi. So I'm going to have 2 pi x. And so y is going to equal 3 times the sine of 2 pi x plus 1 since my whole graph is shifted up 1. These next ones then, we are having a word problem where we are going to give the equation modeling the displacement of d as a function of time. In other words, we're going to write the sine or the cosine curve like we did on those first ones, either in the form of y equals a sine of bx or cosine of bx, depending on what you have. So what you kind of want to do is read the problem, sketch out a picture of what it looks like, so then you can look at the graph and think about, well, what is it going to be? It says a buoy is floating at the seas, bobbing in simple harmonic motion with a period of 3 seconds and an amplitude of 9 inches. Its displacement d from sea level at t equals 0 is 0 inches, and initially it moves upwards. So it means it starts here at 0, 0. Initially it's going to move upwards. It has simple harmonic motion, so we're going to have our sine curve. The amplitude, it says, is going to be 9. And the period is 3 seconds, so one cycle would take 3 seconds. So I'm going to have D equals 9 sine of, again, we're going to have 2 pi over b to equal the period of 3. So I'm going to have 2 pi equals 3b, so b is going to equal 2 pi over 3. So I'm going to have 2 pi over 3, and instead of using an x, I'm using a t. And so d is equal to 9 sine of 2 pi over 3 t. Our t wants to look like a plus sign, but something like that. Move this up for number 14 here. So number 14 says a weight is at the end of a coiled spring and is pushed 9 centimeters above its resting point at time t. So it's going to start up here at 9 centimeters. Moves in downward, oscillating in simple harmonic motion, and completes one cycle in 2.5 seconds. Note that downward is in the negative direction. So it starts here, it's going to move downward and have simple harmonic motion, which tells me here if it's starting up here and moving downward, I have my cosine curve with an amplitude of 9 since it's starting 9 centimeters above there. So 9 times the cosine. One cycle takes 0.25 seconds. So 2 pi over b is going to equal 0.25. Now I probably would change 0.25 into 1/4 since I've got a fraction here. So I'm going to say 2 pi over b equals 1/4. And then I can solve by cross multiplying. So 8 pi is equal to b. I'm going to have 9 cosine of 8 pi t then, since I'm using as a function of time. And so d equals 9 times the cosine of 8 pi t would be my equation. Number 15 says an object moves in simple harmonic motion with a period of 5 minutes and an amplitude of 16 meters. At time t equals 0 minutes, its displacement is 0 meters. So again, this one's saying it's starting at 0, 0. It initially moves in the negative direction, so it's going to go down first and do my sine curve going in the negative direction first. My amplitude is 16. So I'm going to have negative 16 times my sine, since I have my sine curve. My period is 5 minutes, so 2 pi over b would equal 5. So 2 pi would equal 5b. So b is going to equal 2 pi over 5. So I would have 2 pi over 5t. And so d is equal to negative 16 sine of 2 pi over 5t. So you can see here, even though it said this one started and moved in the negative direction, it still had a positive amplitude because it started up here at 9. Where this one went in the negative direction first, I had the sine curve and it went negative first. It had a negative 16 there. Although technically the amplitude is 16, the value in front of my sine is negative 16 to show that it goes downward first. So it helps to sketch out the picture of your graph before you try to write your sine or your cosine curve. So 16, 17, and 18, again, we have some word problems that we're going to do. Based on sine and cosine functions, the population size of many animal species rise and fall over time. Suppose the population size can be modeled by the following function. P of t equals, this would be my starting population, 2,680, and then it's going to change by 1,280 times the cosine of 1.4t. In this equation, P of t represents the total population size, t is the time in years. So first of all, if I'm looking for the amplitude of P, again, my amplitude is that number, it's the absolute value. of 1,280, so we'll still get 1,280. My period again is still 2 pi over b, so if I take 2 pi and I divide it by 1.4, I'm going to grab my calculator in order to find that because they want us to round to the nearest hundredth. So for pi, you could use 3.14159, but I would recommend you just use the pi on your calculator. So 2 shift pi, so you see 2 pi divided by 1.4. Use the division instead of the fraction because you do want a decimal answer. And you end up with 4.4879. We're rounding to the nearest hundredth, so I would say 4.49 meters when I round that off. My frequency of cycles per year, how many cycles per year am I going to get? I'm going to basically just flip my period upside down and do b over 2 pi. So I'm going to have 1.4 over 2 pi. And again, I would just use my calculator and do 1.4 divided by 2 shift pi. So the 2 pi shows up right under, or right behind the division. And so I get 0.2228, rounding to the nearest hundredth. I have 0.22 cycles a year. In other words, it takes a fifth of a year, or a fifth, does 1/5 of a cycle every year. It takes 5 years about to do one whole cycle then. So, amplitude, again we get from the A value, period 2 pi over b, frequency b over 2 pi. (17) says, a person sitting on a Ferris wheel rises and falls as the wheel turns. Suppose that a person's height above the ground is described by the following function. So we have 18.8 plus 17.5 sine of 1.6t. In this equation, the height above ground in meters is in meters, and t is the time in minutes. So we want to find the maximum height above the ground. Well, this is my starting shift. I shifted up 18.8. My amplitude is 17.5. So if I take 18.8 and add my 17.5, I get 36.3. So 36.3 meters is going to be the maximum height that I am above the ground. Frequency, we are going to do b over 2 pi, and so my b value is 1.6, so I'm going to take 1.6 divided by 2 pi, 1.6 divided by 2 shift pi, gives me 0.2546, I'm rounding to the nearest hundredth, so 0.25 revolutions per minute is my frequency. The time for one complete revolution is asking for your period. The period is one complete cycle, right? So I'm going to say that I have 2 pi over b, so 2 pi over my 1.6. So 2 pi divided by 1.6 gives me 3.926, rounding that off to the nearest hundredth. 3.93 minutes is how long it would take to do one revolution on my Ferris wheel. Last one on this packet, number 18 here, says, the depth of the water in a bay varies throughout the day with the tide. Suppose we can model the depth of the water with the following function. Starts at 22, I'm going to do negative 7.5 times the sine of 51, or 0.51t. So first of all, they want us to find here, what is the minimum depth of the water? So I'm starting at 22 feet, but I'm going to go down 7.5 because of my amplitude, right? My cycle goes up and down, up and down. So if I take 22 minus 7.5, 14.5 feet would be my minimum depth. My period, 2 pi over b, So 2 pi divided by 0.51. So 2 shift pi divided by 0.51 would give me 12.319. So I'm rounding to the nearest hundredth. 12.32 hours then is what I would round that off to. The number of tidal cycles per hour is asking for your frequency. How long does it take to do the cycles in cycles per hour? So I am going to take b over 2 pi, and so 0.51 divided by 2 pi, 0.51 divided by 2 shift pi gives me 0.0811, rounding to the nearest hundredth, 0.08 cycles per hour then is what I would have for my frequency.